Before we begin, I want to go over some ground rules. Parents, please help your kids mute their mics and keep them muted during the entire event so that we can all hear our presenters clearly. If you ever have a question, please just type it into the chat. Now, we're going to introduce ourselves. Who are we? We are Team 118, the Robonauts, and we are a robotics team with students from 6 high schools in CCISD. Something cool about us is that we get to build robots out of NASA Johnson Space Center with real NASA engineers. Now, we're going to show you a video so you can see the robots that we get to make. So now that you've met our robot, it's time to meet our instructors. Hey y'all, my name is Tatiana Vasilia, and I am going to be an 11th grader at Clear Lake High School. I first started robotics in 4th grade through a Girl Scouts robotics team, and I've loved robotics ever since.
Hey guys, my name is Philip Bortolotti. I'm going to be a 12th grader at Clearbrook High School. My first experience with robotics was actually only 2 years ago at Clearbrook in my 10th grade year when I joined my school's VEX robotics team. From there, during my 11th grade year, I joined the CCISD Best Robotics team, Jigsaw Robotics, and I also joined the Robonauts. When I grow up, I want to be a mechanical engineer.
Hey guys, my name is Hannah and I'm going to be in 11th grade. I started robotics in 4th grade at Landell Elementary, right where some of you are now. I was on robotics teams all through middle school, and now it's a huge part of my life. When I grow up, I want to become a biomedical engineer and design medical tools that can save lives.
Hey everyone, my name is Jonathan, and I'm going to be in the 11th grade at Clear Lake High School. My first experience with robotics was in the 3rd grade, and ever since then, I've loved it more and more.
Hey guys, my name is Mamta. I'm in 12th grade at Clear Lake High School. I've always loved math and science since elementary school and got into robotics in high school. It is now basically my life, and I want to be a computer science engineer one day.
Hi everyone, I'm Joel. I will be a 12th grader at Clear Lake High School. I started engineering at 5th grade at Ward Elementary, and it's been a big part of my life since then.
Hi everyone, my name is Sophie and I'm going into 12th grade at Clear Lake High School. I participated in engineering activities through middle school and I had my first robotics experience the summer after my 10th grade year. When I grow up, I want to be an environmental engineer.
Hey guys, my name is Grena Vasquez. I am an incoming 10th grader at Clear Falls High School. I discovered engineering in the 3rd grade, then joined the team the next year, and I've just been hooked ever since.
Hi, my name is David, and I'm going into 10th grade at Clear Falls High School. I've been doing robotics since 7th grade, and I've been passionate about robotics ever since.
All right, everyone. I want to talk to y'all about our agenda for today and what we're going to be doing. First, Y'all are going to be gathering materials for a secret challenge. I can't tell you what it is yet, but I promise that it's going to be awesome. Next, we're going to tell you a little bit about what engineering is, what makes it so cool, why we do it, and why you should do it too. Then, we're going to teach you about the engineering design process, which is a huge part of being an engineer. Then you are going to have the chance to think like real engineers, just like we do at the Robonauts. Lastly, everyone is going to do that super fun challenge I told you about earlier, so stay tuned. Okay, everyone. So now really quickly, if you haven't already brought your materials, I want you to get these items. You need a piece of paper or an index card, 5 straws. If you only have 1 straw, that's okay, but 5 straws will make it more fun. You need some tape and some scissors. Everyone, please be very careful with your scissors. Parents, we ask that you keep an eye on your students when they cut to prevent injuries. It's going to be much easier if you cut up a few strips of tape right now and have them ready for the experiment. Now, if anyone doesn't have a straw, we're going to show you a quick way to make one. Take a look at the screen right now. Hannah is going to grab a piece of paper and a pencil, and she's going to wrap the paper around the pencil as tightly as she can. If it's a little loose, that's fine. Just make sure to keep wrapping. She's going to keep wrapping until she reaches the very end of the paper, just like you see, and then she's going to slide the pencil out of the paper and wrap one of her pieces of tape around it. Voila! Now you have a straw. All right, I'm going to give y'all 30 seconds to get your materials ready and your tape strips cut. If you need more time, feel free to take a picture of the slide and keep gathering your materials. Okay, now that you've gathered your supplies for our challenge, let's learn more about how engineering is all around us and why it's so cool.
Engineering is all around you. In fact, pretty much everything you can see right now was built by an engineer. Today we're going to teach you how to think like engineers. This is a roller coaster, something most of us have probably seen before. But did you know that it took countless hours of engineering to make it fun to ride and also safe for everyone? This is a hoverboard, something y'all have probably seen or maybe even own one. It's surprisingly similar to the roller coaster, even though they look really different. The hoverboard also took many hours of engineering to create. Engineers got the idea from a skateboard and over time created this, a hoverboard that is fun and safe for everyone.
Alright guys, we're going to take a short break for today's mystery engineering object. This item is something pretty cool I found in my house, and fun fact, what I'm about to show you is just a tiny version of the real thing, which is almost 10 feet tall. It was invented in 1991, which is almost 30 years ago. I bet you're all excited to know what today's mystery object is, so here we go. Drum roll, please. Today's object is a wind-powered walking robot. All right, let's check out the real thing. Now what I have here today is just a smaller version of what you saw in the video. And it looks a little different too, right? That's because over 30 years, engineers have perfected it and changed it so much so it can work better. Remember in the video where one of the robots fell? That failure was how the engineers learned ways to make the robot better, and all the features after that helped us get this final strand beast. This strand beast is wind-powered and it walks sideways. All those legs that you see help the robot walk. I know some of you are probably thinking, wait, Hannah, you told us that this robot was wind-powered. There's no wind in your house. So what is making this robot move? This right here is a tiny fan that helps spin that propeller. All right, let's dive in a little deeper and learn how this works. Take a closer look at this propeller. You see that tiny gear right there? That tiny gear is connected to all these much bigger gears, and they all connect at this point right here. This is a rod. This rod goes through the entire middle of the robot, and all those little spider legs that you see are connected to that rod. So if these gears spin together, it makes the rod spin, and if the rod spins, the legs move. Watch what happens if I spin the rod. Do you see those legs moving? And that's today's mystery engineering object. Cool, right? Next, Jonathan is going to explain why engineering is so awesome.
There are many reasons why engineering is so cool. First, engineering saves the world and lives. From cool machines they use to protect nature, and all the way to robots used in hospitals to clean rooms, engineering has been used to help improve the environment and people's lives. Second, engineering is all around us. Look at the home around you. Look at the video games you love to play. And look at the lights in your room. All these things have something in common. Engineers have designed them. Another special thing about engineering is that it gives us so many cool things that we get to use and enjoy every day. Take the computer that you are on right now as an example. Engineers have spent countless hours working on that computer and making it better and better. And lastly, engineering is such a fun subject to get into because you're able to do anything you set your mind to. And the best part is there is something for everybody. From engineering of sound and making music, to designing rockets that will bring astronauts to Mars. There's something for everybody to love within the subject.
There are 6 basic questions to ask when understanding something. Who, what, when, where, why, and how. First, who are engineers? Engineers are people who invent, build, test, and analyze machines and structures to meet requirements towards a goal. What is engineering? Creating technology and machines to solve problems. When can you start? You can start anytime. Where can you start? You can start at home. Try new ways to fix problems around you, whether they be in school, at home, or in your community. Why be an engineer? As Jonathan said, you can help save people, improve life, and have fun. How do you become an engineer? Study the world around you as it's full of engineering creations and many more challenges that need to be solved.
If you have any questions so far, leave them in the chat. We'll answer them as best as we can throughout the presentation. Our first question is from Posey, and she asks, what is your favorite robot you guys have made so far?
So I think my personal favorite was the robot that the robotics team, the Robonauts, built a couple years ago, back in 2013. And that robot, the purpose of it was to shoot frisbees. And I mean, I, for one, like throwing frisbees around myself, so it was really interesting to see a robot that also did it.
My personal favorite is Ruckus in 20. I've had bad at years, but it's pretty cool how there's so many balls shooting really fast and how the engineering behind it made it possible.
Awesome. Does anyone else have any more?
My personal favorite robot is the robot we made in 2015, which was, for those of you who were here before 1 o'clock, it was the really, really tall one. I like that one because it's just a really beautiful robot, and we also won the World Championship with it.
I guess continuing on this, I guess my favorite robot would probably have to be the 2018 robot, Illusion. And it was the one that I was dealing with before 1 o'clock with the yellow cubes and putting them on these tall platforms. The way it moved, I love that robot so much.
Okay, guys, we're moving on to the next question. Katie asks, do you control or code the robots?
Good question. We actually do both. So there's a period at the beginning of the match where everything is just coded, so the drivers aren't allowed to touch the little joysticks. But after that, the drivers move the robot around the field and score game pieces.
Awesome. Kayla asks, how long did it take to build the frisbee shooting robot?
So we actually have a 6-week build period for every one of our robots. So that robot also took 6 weeks to build.
In those 6 weeks, we usually work about 20 or plus hours behind the scenes to have that be the best it can be.
And she meant 20 hours a week.
Awesome. We're going to move on with the presentation now.
So guys, next on we're moving to the engineering design process. Every engineered object that you see throughout your everyday life was probably created using this process. It is the basis of all engineering products, and following it will help make your engineering journey much more fun, organized, and simple to follow. Now, here's a model of the design process. As you can see, the first step of the design process is ask. The first question you will ask yourself is, what problem are we trying to solve? Every invention that was engineered came out of a problem that needed to be solved. For example, a broom was created to solve the problem of needing to clean dirty floors. The next thing you will ask yourself is, what product will solve this problem? This begins the brainstorming, where you and your group come up with ideas. Any product you see now probably had a lot of ideas made before it was chosen, so it is important to look through options with your team to choose a good idea. This leads us to the next step, explore. Exploring is a way that you can learn more about your problem and your brainstormed ideas in order to come up with a better solution. This includes research, talking with people who experience the problem, and generally finding out information that will help you come up with a solution. You will also explore the criteria and constraints. The criteria is basically what your product needs to be able to do, and the constraints are the things that limit your product, like size limits, cost limits, and time limits. Once you've done this, it is time to move on to the third stage, model. In this stage, you first need to weigh your options from brainstorming, research, and the constraints and criteria and choose the best idea for you. Once you have done this, it is time to prototype. Prototyping is basically making a model of your idea to test it out. Once you have made a model, you can move on to the evaluate stage, which means looking at the strengths and weaknesses of your prototype and improving it. This repeats many times because you need to make sure your product is just right. Once you do this, you can move on to the final step, explain. This step is basically where you discuss the product you made with your team, your boss, or any other people who need to know what is going on. Here you will look back at the problem and see if your product solves it. If not, that's okay. If you can see the picture, the arrows go both directions. And this is to show you that it is not just a process that only moves forward. If your model isn't working out, maybe you should go back to the explore stage and do more research. If your idea isn't being explained well, maybe go back to the modeling to prototype a different idea. It's all about being flexible and creative to come to the best product you can to solve your problem.
Now that you have learned about the engineering design process, it is time to think like an engineer. We will walk you through the engineering design process, first starting with defining your problem.
Okay, I want you to meet Nathan. He's a tiny paper friend of ours who loves to go on adventures and explore the world around him. He needs your help to create a flying object so that Nathan can travel around a room in your house. Let's think. How can we create something that can fly? I want you to take 10 seconds and tell us what you think in the chat. All right.
Now that you have been introduced to our problem, you will need to do some research to better understand certain parts of the problem. Since you need to design something that can fly, you will need to understand how an airplane flies. We are going to do some research by showing you a fun video on how airplanes fly.
Ahoy! Let's think. Today we answer the question, how do planes fly? Look up at the sky. It's a bird. It's a plane. It's a... Wait a minute. It's a plane. For an object that can weigh up to 500 tons, how can a giant piece of metal fly and stay up in the sky? For a plane to stay in flight, it needs 4 forces to work together. Thrust, lift, weight or gravity, and drag. Thrust is what keeps the plane moving forward. Depending on the plane, there are different methods to produce thrust. A jet will use its jet engine, while other planes, such as a crop duster, will use a propeller. Lift is what keeps the plane up, and is one of the reasons why a plane has wings shaped the way they are. Many planes' wings are curved at the top and smoother at the bottom. This allows the air passing over the wing to move faster, which decreases the air pressure. Since the air pressure above the wing is lower than the air pressure below the wing, it causes the plane to lift. Drag is the force that slows the plane down. You've probably experienced drag when you had to walk against a strong wind or have gone skiing down a hill. For a plane to stay in flight, it must have stronger lift than drag. Similar to how the wings help with increasing lift, the shape of the wings will also help with decreasing drag. Weight is caused by gravity and is what forces the plane down. The plane is designed the way it is to distribute the weight evenly throughout, rather than concentrated in specific areas. When all 4 forces are working together, this causes the plane to fly. Lift and weight work together to move the plane up and down, while thrust and drag work together to speed and slow the plane down. Lastly, you should always have a pilot. Just like a captain steers a ship, the pilot steers the plane to its final destination. So that answers how do planes fly. That took some thinking.
Before we begin to brainstorm and solve our problem, we need to know what our constraints and criteria are. A constraint is a limitation or restriction, which are kind of like a set of rules. If you decide to join your elementary school team, all you're going to get to build your entire robot is a big box of materials. That is an example of a constraint. Your robot rulebook might give you some more constraints too, like how big your bot can be. When you design solutions, you always need to make sure you stay within your constraints. To solve Nathan's problem, we need to design something that can fly. Think about what your constraints could be. We only have a couple of materials in front of us. Since Nathan is designing from his house, his solution can't require any tools that aren't in his house. This is one of our constraints. Our other constraints could be that we don't have a lot of time to design and build it. We do not have an unlimited amount of money either. These are some of the constraints that can limit your design. Criteria tells you what you need to do. On any of the robotics team at your school, you'll use that big box of pieces to build a robot that moves. The rulebook is going to give you what your robot will need to do in order to score a ton of points. A robot that moves or a robot that can pick up cubes are some criteria that you might see at some point in your robotics career. When you're designing a solution, you need to make sure that it meets all the criteria. Now let's think. What kind of criteria do we need to follow for Nathan's flying contraption? Some criteria would be how we need to make sure Nathan's design can stay in the air. We also need to think about how far Nathan's contraption needs to go or how long it needs to stay in the air. What about the design flight path? Do we need to be able to make sure that Nathan can control his path of flying?
The next step in the process is brainstorming. Brainstorming is my favorite step. The most important part of brainstorming is welcoming any and all ideas, even out of the box and especially original ideas as how to solve our problem. In the chat, someone mentioned helium as a really unique idea. I love that. We all know Einstein and Newton as super awesome genius scientists, but in their time, Einstein and Newton were not known as those great scientists we know them as. When they were alive, their brilliant ideas were just brushed off by other scientists because they were so out of the ordinary. But if we think about it, their creative and innovative ideas brought us so many great engineered inventions today. Now we're going to brainstorm some ideas on how to help Nathan. Think about the criteria and what we've already talked about. What can you design that follows the criteria and helps Nathan fly across your house? Put some ideas in the chat.
Come on, guys, leave your ideas in the chat. Oh, Micah suggests a blimp. Lucas suggests that the thing be lightweight and sleek.
Lucas, that's a great idea.
Wayne thinks we should use a rocket, while Gavin thinks we should use a paper airplane. And so does Celeste. Lucia thinks we should have wings. And Andy, Ian, and Colin think we should use a hot air balloon. Oh, and so does Kayla. These are all great ideas, everyone.
Now, in order to move on to the modeling step of the design process, we need to choose a solution. After doing all the brainstorming you can and coming to a team decision, it is time for you to decide which idea from your brainstorming is the best. This can be a hard process. After all, you guys may have come up with so many great ideas as a team, like you guys just did. The best way to decide which idea is the best is to weigh it with your criteria, remember what your product needs to do, constraints, which is what limits your product, and the problem, which is the issue that your product will solve. Ask yourself questions such as, which one follows our criteria? Which one is the least expensive? Which one is the easiest to build? Which one is the quickest to build? Asking yourself questions like these helps to decide which solution is the best. In our case, we can ask ourselves, which flying object flies the farthest? Which one is the hardest to create? Questions like that.
I personally love the prototyping step of the engineering design process. Prototyping is testing your ideas from brainstorming. You make your ideas in a less expensive way by making your solution from cheaper or smaller material. Do not be discouraged if your prototype fails. Keep trying, as this is the step you will learn the most from.
All right, guys, it's time to answer some questions. Brendan was wondering if there is a Robot Olympics or games because the YouTube videos show different games.
So we actually designed robots for a competition called FRC, or First Robotics Competition. So basically each year, around the time of winter break, they typically reveal a new game. And so we as a team look at that game and we brainstorm and prototype and try to design a robot that we think will get us the farthest in that game. So it's not really an Olympics. It's not like each year we do multiple games. It's just like each year they give us a new game. But we do actually keep the old robots around. So thanks for your question.
So this year, our game involved shooting some balls in a little ring. But last year, we had bigger balls and discs that we had to pick up and place places. And the year before that, we manipulated cubes and moved them onto platforms.
Thanks for your responses, Robonauts. Audia from Brookwood asks, does your robot help NASA engineers?
So our robots are built to play the game rather than like help people in the real world. But it's interesting because some of our former students now work for NASA and are trying to advance robotics engineering and to put people in space.
On top of that,
Awesome.
some of the high school students that are on the team help our mentors with an independent study project, so they can assist their mentor with work.
Thanks, Joel and Hannah. Sonia asks, what software did you use to design the hardware parts?
So on the Robonauts, we used a software called Creo to kind of design our parts and test them out before we actually make them in real life.
Awesome. Thanks, Jonathan. Daniela asks, where do you guys get your ideas to make a robot?
So for us, it's all about brainstorming. As a group, we split up, all of us have different ideas, and then we test it out to see which one works best to solve that problem and play the game.
Awesome. We're going to save the rest of the questions for the next time. Thank you.
All right, you guys. So what we're going to make today is called a hoop glider. I want to go over the materials just one more time in case anyone is missing something. Remember, you need a piece of paper or index card, straws, a good number is 5, some strips of tape, and scissors. I'll give y'all a couple more seconds to get ready.
What do you guys think this is? Based on our research and what we've talked about so far, what do you think we're going to be doing with it? What you see on your screen is called a hoop glider. It's kind of like a paper airplane, but it's so much cooler. So today we're going to prototype and design one of these hoop gliders so our tiny paper friend Nathan can fly around your house. All right, boys and girls, first you're going to get your scissors and cut a long strip of paper. Make the paper about this thick. You want to be really careful with your scissors and make sure your paper is super straight. Parents, feel free to help your kid cut your paper. I'll give you all a few seconds to cut this really long strip of paper. Next, boys and girls, you're going to cut a shorter strip of paper. Make it about half the length of the first one. Now, boys and girls, it's time to use your straw. Go ahead and grab your straw and tape the long strip of paper right onto it, just like this. For this step, it helps to have a couple pieces of tape handy. Don't be afraid to use multiple pieces of tape because we want this to be super secure. Once you're done, pick it up and wiggle it around, just to make sure it doesn't come loose. Parents, feel free to help and make sure the strips are secure. Then we're going to do that same exact thing with the shorter piece of paper. Put it on the other side of the straw, grab some tape, and tape it right on there. Make sure they're super straight and super tight. Spin it around a little. Make sure the paper doesn't fall off. I'll give you guys a few more seconds to finish this. Alright, boys and girls, this step is a fun one. It helps to have a couple pieces of tape ready. What you're going to do is you're going to tape this long strip into a nice round ring, just like this. Don't forget to use a ton of tape. Then you're going to do the same thing with the smaller strip. Grab your tape and tape it into a nice round ring. You want these hoops to be super secure. Take your time with this step. You want to make sure your rings are nice and round. And that's it! Boys and girls, give yourself a pat on the back because you just made a hoop glider. Now it's time for the fun part. We're going to test out how well it flies Nathan around your house. First, we're going to show you a short video to show you how to throw it and what it looks like for Nathan as he flies through the air. Go ahead and find an open space in your house to throw it. Usually just like a gentle throw, kind of how you would throw a paper airplane would work.
Can we make it bigger?
Actually, we're going to test out that in a couple slides.
Okay, guys, it's time for another question break. Tanya asks, do you make all the parts that go into the robot that you build?
Yes. We all on the Robonauts and in a competition, every team has to make their own parts and make their own robot their own way. There are no really pre-built parts except for like motors and electronics, but everything hardware and like the whole robot that you see is typically made in-house or by the students.
Awesome. Thanks, Jonathan. Kayla asks, do all teams go to the same place for the games to compete?
Great question, Kayla. So FRC, which is First Robotics Competition, is a really, really big organization. And so there are so many teams, it's impossible to fit all of them into one competition. So throughout the season, there are multiple competitions in usually each state and also a couple in overseas in Israel. But at the very end of the season, there are 2 world championships where teams from everywhere either go to Detroit or they go down here to Houston to compete together.
Thanks, Hannah. Kristen asks, do some have legs?
Well, we have sort of legs on some of our robots whenever we climb onto some kind of higher land. In last year's robot, 2019, we had to get onto a tall platform, so we had an extending leg of sort that helped us get onto a tall platform.
Thanks, Monta. This next question, please forgive me if I mispronounce your name, is from and he asks, what programming language do you use?
Well, we use C++ and XML at the Robonauts, but a lot of teams use Java and Python as well.
Awesome. Thanks, Momta. I'm going to combine these next 2 questions. Adeline asks, how old do you have to be on the robotics team? And Sonia asks, Myrene asks, if I want to join your team, what do I have to do to prepare?
So joining the Robonauts, it's not really about age. So you can join the Robonauts when you get into your first year of high school. But generally, if you join in your first year, you'll be around 14 years old. And what you have to do to prepare, so first of all, to join, you have to have a certain grade average. So you got to keep your grades up to join. And also, there's like an admissions process where you write an essay and answer a couple questions. So basically, you just have to show that you're passionate about engineering and you're willing to put in the hours to dedicate to the team, because it is a lot of hours you put in, but as long as you show that you're dedicated and you love to learn and that you are interested in engineering, you should be able to get on the team if you try hard.
And awesome. I'm gonna add on to that real quick. Before you get to high school, if you still want to continue and do engineering, I believe all elementary schools and middle schools have some form of an engineering robotics team. I think from 4th and 5th grade, and then all throughout middle school. So you can do it up until high school as well.
And this is if you're in CCISD. If you're in another district, it may or not be in your school.
Okay, Robonauts, thank you for your responses. For everyone asking about changing the hoop glider, that's what we're going to move on to right now. Okay, guys, it's time for testing. Let's change up some measurements. Engineers do this all the time in the engineering process in order to create the best product they can. We're going to change different parts of our hoop gliders to try to make them better. First, we're going to test the placement of the hoops on the hoop glider. Does the placement of the hoops on the straw affect its flight distance? Go ahead and move the hoops to different places on your straw and test what happens. We'll give you a couple of minutes to make this change and test it out. While you're doing this, make sure to talk to your parents or other siblings about the new design. And once you've tested it, Please tell us what happened to you in the chat. We love hearing from all of you. If you look to the left of the screen, Hannah is also working with her hoop glider, so you can get some ideas from her.
There's a lot of Stanleys.
Do you guys need more time? Oh, Gavin asked.
Yes.
Okay, thank you. We'll give you about 2 more minutes.
Thanks. Thank you.
Okay, while you guys are doing that, Gavin said that his went farther 2 out of the 3 times that he tested it. Awesome job, everyone. When I tested this, my hoop glider spent more time in the air and went a farther distance, just like Gavin's. Angelina even told us what she did when she was adjusting. Adjusting means changing the placement of the hoops on the straw. She moved hers more to the middle. Kayla says that hers went farther and faster. Awesome job, everyone. We're going to move on now. Now we're going to change the length of the straw. Does the length of the straw affect the flight of the hoop glider? Go ahead and cut or add to your straw. If you want to cut your straw, please have your parents help you to safely handle the scissors. To add to your straw, you can attach multiple straws together. That's why we asked you to bring 5. Or roll a small strip of paper around your original straw and tape it to the end of your straw. We'll give you a couple of minutes to make this change and test it out. While you're doing this, talk to your parents or other siblings about the new design. Once you've tested it, tell us what happened in the chat.
Mine's gonna be like a bit smaller.
Okay, guys, look at what Hannah's doing on the screen as you change the length of your straw. And please make sure to let us know. If you need more time, please tell us in the chat. Please do not unmute your microphone to speak. Thank you. Okay, while you guys are doing that, I'm going to read what happened to some of the students. Brendan says that 4 out of the 5 times he tested it, it went further. Phoenix told us what he did. He made the straw shorter and it just spun and fell. Kayla says that the short one does not fly straight like the long straw. Rachel says that hers went farther. Angelina told us what she did. She added a straw and 1 hoop. But hold off on adding hoops. We're going to do that in the next testing stage. Benicio says that his didn't fly very well. And JP says his was shorter. And Scarlett says that the longer straw just started spinning in the air. Thanks for all of your responses, guys. When I changed the length of my straw, it did not fly very well and spun around like many of yours did. And we're going to explain why soon, so make sure to pay attention.
Now let's add more hoops to the glider. Do more hoops help the hoop glider fly better? Let's start adding. Now, since we cut our first glider straw shorter, make sure to use a new straw. Now don't forget to line up your new hoops. We'll give you a couple minutes to build the other hoop glider with these changes and test it out. Now make sure, kiddos, to get help for your parents if you need it. Always stay safe. On your left, you'll see Hannah making a new glider. And remember, after testing, to put your results in the chat. We always love to hear from everyone. Wow, look at Hannah go with her hoop glider. I hope you guys are having so much fun like we are. Great job on those gliders, everyone. Make sure to tell us your results in chat. Izzy says, my 3-hoop glider didn't go very far. Personally, when I tested, mine didn't work very well either, until I put the hoops in order from smallest to biggest. Now keep those comments rolling. Mika says, sorry if I mispronounced your name, it looks funny. Yeah, it kind of does, but this is the whole point of testing, to try out those new things. Luke B says, his crashed again. Well, that would just depend where you're throwing it, but thank you for commenting. Do you guys need more time? Jack says that his went straight down. Mine did too. Keep going, kiddos. Okay, time to move on. Here's our explanation of the hoop glider's reasoning.
Let's talk about why exactly the hoop glider is able to fly. Imagine you dropped a flat piece of paper off of your balcony, and then you dropped a crumpled piece of paper. Which one is going to hit the ground first, and why? I'll give y'all a couple seconds to type what you think in the chat. That's right, everyone. It's the crumpled piece of paper. See, the thing is, it's all about air resistance. Here on Earth, air is all around you. When you move through the air, you push on the air, and the air pushes back, which slows you down. If you dropped both objects on the moon, they would hit the surface at the same time because there's no air resistance. So what exactly is air resistance? I want all of you to take a minute and stand up. Spread your arms out really wide and put your fingers together. Now flap your arms around you or spin around. Do you feel the wind on your palms? That's the air resistance that we're talking about, and the air pushing back on your hands. Let me know if you feel it in the chat. Awesome. So what about the crumpled and the flat pieces of paper? What's the difference? It's still paper. Well, the flat piece of paper is straight, and it has more paper touching the air, so it can catch enough air to slow it down as it falls. But the crumpled paper is round, so the air is able to go around it, which means it doesn't slow down as much when it falls. So what does all of this have to do with our hoop glider? Well, the big loop has more paper touching the air, so it's able to catch more air in the back of your glider and keep it flying. The small loop has less paper touching the air, so it catches less air and helps steer your glider. So, knowing all of this, what do you think will happen if we make our hoops wider? If we make just the front loop wider, just the back loop wider, are they going to be able to catch more or less air? How is it going to affect how it flies? I'll give you all a couple more seconds to tell me in the chat. So actually, if we made our loops wider, it's going to catch more air because more paper is touching the air.
Okay, guys. If you want to test any more things with your hoop glider, you can move the placement of the 4 hoops around on the straw and see how it flies. But right now, I'm going to ask if you guys have any last questions. Please leave them in the chat. We're going to answer them in a few minutes when the webinar is almost over. Make sure to leave your questions, guys. We want to make sure we can answer all of them.
Hey guys, so we're just going to do a little review of the engineering design process in the context of the hoop glider challenge we did. So, if you don't remember the steps, they are ask, explore, model, evaluate, and explain. So the first step is ask, where you ask yourself questions about what problem you are solving and what ideas will help solve it. In this case, our problem was getting our friend, Nathan, to fly across the room. The brainstorming is when you asked you guys for your great ideas on how to do this. The next step is explore, where you learn more about the problem and your ideas to know how to start engineering the solution. We did this by researching through that cool airplane video we watched. Next is the modeling stage, where you prototype, another word for model, different ideas. We did this when we made all the different types of hoop gliders, like those with more hoops or with different lengths of straw. The fourth step is evaluate, where you basically look at your prototypes and judge each one by looking at their strengths and weaknesses and solving the problem. We did this when we asked you guys questions about the different prototypes we made. Remember, we did the evaluate and the modeling stages several times in a row, which shows how you can do this process backwards and forwards. Remember that you can always go back in the process if you need to work some things out. The final step of the process is explain, where you take your product and talk about it with your team and other experts to get it perfect and ready to work and solve the problem. We did this when we explained why the product worked and asked you guys how you felt about it solving the problem of flying Nathan across the room. This process is a very helpful and important one because it allows you to engineer solutions in a way that properly solves the problem and works for many people.
So what happens if it doesn't work? Well, boys and girls, not everything is going to work the first time. Did you know that Thomas Edison took 1,000 tries to make the light bulb? But he didn't give up, and neither should you. Engineering is full of trial and error. When something doesn't work, we just go back to the process and we try again.
Okay, guys, we're going to answer your final questions. Please stay if you have any. And yes, as you guys have already pointed out, we are a little bit over. Okay, so Daniela asks, what happens when you're in a competition and the program doesn't work? Well, I'm going to answer this because I'm on the software team or part of the team in Robonauts. And we actually had something kind of similar happen at our last competition, but what happens is everyone in the pit works together to try to work out all of the errors and make sure that our robot can work in our heat. Does anyone want to add?
In situations like these, it gets really hard to keep a calm. It's hard to keep calm, but the most important thing is that in a competition, you have to stay calm.
Okay, and thanks, Hannah. Angelina asks, when did you make your first robot and what did it do?
I can actually answer that. The first Robonauts robot, it was in 1997 and was named Integral and participated in a game centered around getting inner tubes and putting them on posts on like something in the middle of the field. It was like a pyramid. You'd get these little tubes and you put them on a pyramid, and that was the first game that the Robonauts ever participated in.
Awesome. Thanks, Jonathan. Myrene asks, what is the difference between a Vex IQ challenge and yours?
Well, a Vex IQ challenge is a bit more, well, the materials are different, which allows different games. So every year we both receive different game challenges because of our resources and what we can do with the education we've had so far.
Awesome. Thanks for your questions, everyone. We are so glad that you were able to come, and we hope you will be able to come to more in the future. And now Joel is going to close us out.
Thank you all so much for coming today. We hope you've learned something new about engineering, and hopefully you feel inspired to think like engineers in the future. Please post your thoughts about the webinar in the chat. We'd love to hear from you. We also hope you can join us for any future webinars. Keep an eye on our social media channels for more information. And all of our social media information is on the screen right now.